Hey guys, let's continue to the final question of this tutorial. So right now we have some sphere. Here is the sphere. And the shell of the sphere have some electrical charge. Let's put it some plus electrical charge. And its value is, it's a constant. I want you to notice it. But before that, I want to emphasize that the radius of the sphere is R. Okay? So what is this value is? It's P0 over R and E in the power of minus R B minus A. Okay? So I know you feeling like this is not a constant, but hey, it's one sphere in a radius R, so this is a constant value. And the first question is, what is the total charge of this sphere? So Q total question mark. What is the total charge? So okay, from tutorial 1 we remember well that Q total is actually equal to integral of all the contribution of charge, a small contribution. And this one is equal to integral of the surface charge, right? This is a surface charge only on the surface, multiplied by some ds, which is unit of area. And I want to remind you that this is a constant, so this one can go outside. If this one going outside, it's actually sigma ds. And the sigma of ds, if I'm going to sum, here it is, all the small pieces of area on this sphere, what is the total area that I'm gonna have in the end? It's actually the sphere itself. So I remember by heart what is this size is. It's 4 times the size of a circle, pi r squared. This is the way for me to remember it. It's important that you would have this one in your sheet paper for your exam. So I have this value, and we calculate, we just need to put q inside, so the total q total is actually equal to what? To sigma. We know what sigma is, so let's write also sigma. So it's P0 L exponent minus L B minus A multiplied by R pi L square R square. And this R can go with this one. So we actually got Q total is P0 4 pi exponent minus L B minus A multiplied by L. Perfect. We have this one, so we can clean this board a little bit. Perfect, we found what is the total charge. And the second question is what our tutorial is dealing with. Is dealing with the potential. So it's what is the potential? What is the potential inside the sphere in this location? Here it is. Hop, this location. What is it? So you learn in your lecture that this is equal to K, constant, Q, the charge of the sphere, divided by R, the distance of the sphere from the origin. So we know everything here, right? We know R is given, Q we just calculated, and K is also a constant. So we can start writing this. Perfect. So this one equal to what? It's equal to 4 pi K, right? This R gonna go with this R, you can see it. So I'm gonna write P0, 4 pi already did, exponent minus L B minus A. Perfect, that's it, right? Phi in equal to this term. Very good. Okay. So the last question is a little bit tricky. Okay? What they're saying in the last question, they actually taking this idea of sphere. Let's leave it here like this. And they said they're gonna take a small sphere. Let's do a new drawing. They're gonna take a new sphere, but this time its radius gonna be A. The same A that you have here. A, some constant. And you're gonna put on top of this sphere another sphere. and another sphere, and another sphere, and another sphere, until they reach radius B. This is radius A, this is radius B. Okay, let's. For me, it's hard to look how it's look like. Oh, here it is. Now it's better. Until I reach B, and they ask me what is phi in now in this configuration. What is the total? But what is the potential? It's driving me crazy. Okay, so. Okay, now it's better for me. Okay, so what is the total potential of this hollow sphere, right? This is now a sphere with the thickness, this thickness which is B minus A, this is the thickness, right? And what is the potential of all of this shape? This crazy question. So what I want you to notice, and we don't need this one, and we don't need, okay. So how I can solve this kind of question? So what I'm gonna do, I'm actually gonna say that the total phi in is actually the superposition of all the small sphere. You can see that here we solve this question for some sphere. You see, this is a general case of a sphere with radius R, some distance from the origin, not A, not B, but something in between. So this one is equal to the summation of all the potential from every, right, from every sphere, in every radius, right? And if I have a lot of these spheres, let's say that the thickness, look, right now if you want to build this kind of a sphere, or not sphere, of a ball, it's a kind of a ball, right, which have a hollow inside, we need to have some thickness to our spheres, right? So let's say that this thickness is dr. So this actually need to have some also charge due to the thickness of this shell, right? So I'm gonna add here dr to fix it. This is becoming a rho. Here in the end I'm gonna have dl, right? The total charge on some sphere. I have here dl, and this dr I'm gonna add also here because we put the total charge of a sphere inside here. So we have this dr. And right now this also have some dl inside it. And I'm gonna clean this one up. Here it is. And we're looking for the total charge here in the middle. Not total charge, total potential. So, if I have a lot of sphere, and I do have a lot of spheres because I chose a really small thickness to each sphere, this thing, the summation can be an integral, right? F as a function of R in each location, you see its dependency on R. And here I have this dr, because I announced that right now my spheres have a really small thickness. Okay? And I know this value. What is this value? Is all of this, which is 4 pi k p0 exponent minus r b minus a dr. And what are the distances from the origin that I'm going to some spheres? The first sphere appear at A, so this is the lowest value, and the upper value is the top, the biggest sphere that I have, which is A till B. So this is the integral I need to solve out, and this is gonna give me phi in. The idea of this question is to give you another perspective how to look at the potential and superposition idea specifically, and this would really help you in your homework. So I wish you good luck in your homework, and it's really important. This is like a kind of a turning point. So next tutorial we're going to take care of capacitors, and capacitor is the first electrical component we're going to use. And this idea of Gauss's law and also electric potential, it's right now going to come together in order to solve the capacitors idea into a really interesting subject. So work on the homework, prepare yourself to the next tutorial. I'm going to see you next week. Good luck.